is a really cool thing. So get off your ass, let's do some math.
Alright, I hear you need to find the area of a parallelogram. Well, you've come to the right place. Just before we start talking about the area of a parallelogram, I thought we'd remind ourselves of what a parallelogram actually is. Well, a parallelogram is a quadrilateral with opposite sides parallel. You can see that the opposite sides here are parallel. You can see I can move this parallelogram anywhere and it still remains a parallelogram. In fact, in this shape, it's a rectangle, which is a special kind of parallelogram. So some of the properties of a parallelogram include, as you can see here, the opposite sides of a parallelogram are equal. No matter what the parallelogram is, the opposite sides are always equal. If we look at the opposite angles, you can see that the opposite angles are also equal. And no matter where I move the parallelogram, the opposite angles of the parallelogram are always equal. And if we look at the diagonals, you can see that the diagonals cut each other in half. No matter where I move it, those diagonals have the property that they always bisect each other. So let's move on to finding the area of a parallelogram. There are several ways of doing this. I'm going to go through a few. The first method of finding the area of a parallelogram is to divide it into two triangles. So I'm going to draw the line in here, DB. You can see it's divided the parallelogram into two equal triangles. So we need to find the area of the triangles and multiply it by 2 because there's two of them. Okay, so in this triangle DBC, I'm going to call this side the base B. And remember, the height would be the perpendicular height. So that's the height that makes it perpendicular to the base. So this length here would be the height. Okay, so area of triangle DBC is a half times the base times the perpendicular height. So the area of the parallelogram ABCD is that triangle multiplied by 2, which is the base times the height. So the area of a parallelogram is simply the base multiplied by the perpendicular height. Notice the perpendicular height is at right angles to the base. Another way of thinking about finding the area of a parallelogram is to take a rectangle and shear it, that is, kind of push it at the top so it's parallel. So you can see that the area of the original rectangle that is now missing is now moved over here in the blue section. So the blue section has the same area as the original rectangle there. So if I move it a little bit more, you can see again, this area that's missing from the blue part has now come over. So the area of the parallelogram is the same as the base of the rectangle when it's not sheared. So again, the area of the parallelogram would be base multiplied by height. The next way of trying to find the area of a parallelogram is to think of it as a triangle rotated. So you can see in this triangle here, we've got the area of the triangle is half times the perpendicular height, half the base times the perpendicular height. So if we rotate that triangle 180 degrees about the centre point of one of its sides, like so, you can see now that that forms a parallelogram. The green section and the red section form a parallelogram. You can see that because it's been rotated 180 degrees, that this side and this side are parallel, and this side and this side are parallel also. So it must be a parallelogram. So to work out the area of that parallelogram, it's going to be 2 times the area of this triangle, which is a half the base times the height. So it's 2 times a half times the base times the perpendicular height of that triangle, or the perpendicular height of the parallelogram now, which of course is equal to the base multiplied by the height. The final way we're going to find the area of a parallelogram is by doing some sort of cutting. So if you notice in this parallelogram, if we call this the base, the perpendicular height would be this length here, and that is perpendicular to the base and meeting the opposite side. So if we now just rearrange or cut this triangle off here and move it, as we'll see, there we go, and we just move that triangle over there, you can now see we've rearranged the parallelogram, that shaded area there, which is now a rectangle. Now, of course, the area of a rectangle is the length of the base, which is the same as the parallelogram, times the height of the rectangle. So again, the area of a parallelogram is base times height. So we've now seen several ways of finding the formula for the area of a parallelogram. We've decided it's the base times the height. But remember, the height is the height that's perpendicular to the base. It's not one of the sides of the parallelogram. So for example, if we have a parallelogram in this orientation, and if this is the base, then the perpendicular height would be the length that's perpendicular to the base and meets the opposite side. We could have a look at a parallelogram in a different orientation, and let's say of course these sides are going to be parallel, and if this time, if we know that this is the base, then the perpendicular height would be the line that's perpendicular to the base, and that would be the height there.